Okay, how to count atoms. So if we take a look at these compounds that we have in chemistry, they contain a certain number of atoms, and so chemical formulas use chemical symbols, okay, found on the periodic table. Okay, much like our example here. Element symbols are either one capital letter or one capital letter followed by a lowercase letter. Okay, which you've I'm sure seen. For example, using H for hydrogen and He for helium. Okay, when counting atoms of each element in a chemical formula, first we need to identify which atoms are present. Okay, next we look for subscripts. I'll explain. Okay, well maybe I'll just show you now. This is a subscript. These little guys below. Okay, and this guy right here is the coefficient. Okay. Um, So first we look for the subscripts. The subscript affects only the atom that it follows. So this means that there are two H's, okay? If you were just to look there. If no subscript is written, the atom is considered to have a subscript of 1. Okay, you could always assume if there's nothing written that it's a 1. If a subscript follows parentheses, okay, or brackets, right? The subscript of each atom in the parentheses is multiplied by the subscript outside of the parentheses. I'll go through an example of that in a minute. Rewrite the problem after these calculations. Okay, finally, we identify the coefficients. This is what I was talking about here. These are the coefficients here. It's the last thing. Coefficients are distributed to all atoms in a chemical formula. Okay, the coefficient is multiplied by the subscripts. If no coefficient is present, it is assumed to be a 1. Again, okay? Let's work on some examples. So, and you'll need to know this for grade 10, okay? This is foundational for grade 10. So let's continue here. So our example, 3H2O, that's how we would say it. Okay, so the first thing we need to do is identify the atoms. Okay, so I'm identifying the atoms that are present. There's an H and an O. Okay, so I write down an H and an O. And so I happen to have a little table here that helps you to visualize and see what I'm talking about. Hydrogen is an H, oxygen is an O, right? Then we're going to identify the subscripts of the H and then the O. So I have them written down here as 2 and 1. And the reason for that is H has a 2 and O has nothing, right? Which means it's a 1. Okay, and so that's why there. Okay, the last thing is to identify and distribute the coefficients. Okay, and so the coefficient is 3 here. Okay, and so 3 times H, the number of subscripts for H is 2, right? So 3 times 2 is 6. Okay, now we do it for O. 3 times the subscript for O, which is 1, so 3 times 1 is 3. Okay, so that's a total of 9 atoms. So there are 6 hydrogen atoms and 3 oxygen atoms for a total of 9. Okay, here's another example here. And this one contains the parentheses I was talking about, or the brackets, and how that's going to work. Okay, so what I want you to do is, okay, first we have to identify the atoms that are present. Okay, so CO, okay, or cobalt is the first one. N, okay, or nitrogen, and O, which is oxygen, right? So we've identified them first. Then we need to identify the subscripts. Well, as we go along, there's nothing written for CO, so that's a 1. There's nothing written for N, so that's a 1. And there is a 3 written for the O, right? So that's a 3. Okay. So we identify the subscripts. Okay. Now, NO3 happens to be what's called a polyatomic ion. We won't get into that a whole ton, okay, but it means that there are 2 of them. okay? But we've broken it down into N and to O, and that's okay, that's fine, it'll work too. So this subscript needs to be distributed because it is outside of the parentheses, okay? That means that this needs to be multiplied by everything in the brackets, okay? So, and that's what you do when you have parentheses, is whatever is on the outside, you multiply by what's inside the brackets. So we take the N and we multiply 1 by 2, right? Here's 2 times N subscript, so 2 times 1 is 2, so that stays as 2, or that changes to a 2. And then over here we have a 3 for the O, right? So 2 times the O subscript, which is 3, so 2 times 3 is 6. Okay, so now these numbers, if we took the brackets off, okay, these would now be 2 and 6. Okay, the problem can now be written down as this. Okay, so this is, yeah, like I just said, it's rewritten as CO N2O6. Okay, identify and distribute the coefficients is the next thing that we do. The coefficient of 4, right here. So we go 4 times 1, 4 times 2, and 4 times 6, because remember we've rewritten them here as 2 and 6, right? So 4 times 2 is 4. 4 times 1 is 4. 4 times 2 is 8. And 4 times 6 is 24. Okay, so 4, 6, and 8 for a total of 36. So that's how you count atoms.